Lesson 18 for our Course 1 math students has to do with average and line graphs. Kind of two seemingly unrelated concepts. Let's look at average. You've maybe heard of average before. Another word for it in math is the mean of a set of numbers. But average is tossed around in the world. And you talk about someone who is kind of average in their skill of something. Maybe you could say that they got an average grade on the test. Average is supposed to be a C. I might argue that average for our school is more like a B, maybe a B plus. It just means regular, right in the middle. If everyone were put into groups, what would it be right in the middle of each group? Another way, if we took everything and we evenly grouped it, how many would be in each group? Looking at books, I've got a stack, a middle stack, and a small stack. What's the average number of books in a stack, right? It's not how many are in this one or in this one because they're different. We couldn't say that this is average because look at how little there is in this one. And we can't just take this minus this and say that difference or something like that. We need to factor in every stack. What if this one was a lot closer to this one? It would mean that the average is a lot more versus if this was a small stack, it means the average is less. So the way to think about average in this case would be, let's make 3 stacks, but let's make them all the same height so that if I lay on top of this stack of books, it would be flat and comfortable. Now, if they're all the same height, assuming all the books are the same width, that tells me that each stack has the same number of books, 1, 2, 3, 4, 5. We just count 5. 5 in each group. 5 is the average. We did 3 even groups and counted what one group is in that case. Okay, that's what average is. Stack it into even-sized groups, then count how many are in those groups. How many are in evenly grouped amounts? The average number of books in each stack is greater than the number in the smallest and less than the number in the largest. It's always going to be somewhere in the middle. You can find that by making equal groups. In 4 classrooms, there were 28 students, 7, 26, and 31. What was the average? First of all, I think put them in order. 26, 27, 28, 31, or the other way around, just so you've got that in mind. They just go right away and they add them up. The average is how many students there would be in each room if we made the numbers equal. If we took 4 classrooms and we spread the kids equally, not worrying about how many there were in each group, but just how many then would end up in each classroom if it was an even amount. And the quick trick to this they show is you got to add up to find the total sum, okay, of all these numbers is 112 in all. That's all our books, all our students put together. And you take that in all number, our total, and you divide it by the number of groups. Number of groups. We have 4 classrooms, so this number should be a 4. And there were 112 in all, so this number is 112. You divide that out, you get 28 is the average number of students per classroom, 28 students. So if the groups were equal, there'd be 28 in each room. Average is 28. So what were the steps there? You can do your total divided by number of groups. This symbol means number of groups. Gives you average. Make sense so far? Example 2 says, what if we had to find just the average? We don't know what they are, but 3, 7, 8. Add them up, get 18, divide by the number of numbers, or number of groups. There were 3, so the average of 3, 7, and 8 is 6. Is that smaller than the biggest number? Is it bigger than the smallest number? But it wasn't necessarily the middle number. That number doesn't mean anything. It's just another number in the list. So the middle in the list is not the same thing as the average. Very different, actually. That's called the median, and we'll talk more on that another time. Real life situations could be, your free throw percentage average, your average number of free throws you make, I should say, per game or something like that, your average speed per car trip, your average grade in a class. Average can be used in so many scenarios. It can even be used to find the halfway point between two numbers, like 27 and 81. If you're given two numbers and you say, what's halfway? That's the same thing as saying, what's the average between these two numbers? Add them up, 27 plus 81. You can check me in the calculator, but 108 divided by how many numbers? Halfway means there's two. Divide that out to an even 54. 54 is the number that's halfway between those two numbers. Now, line graphs is our last thing today. They display numerical information as points connected by line segments. Maybe you've seen something like this before. Generally, you see a line graph like this, you can tell something is what? Shrinking? No, growing. And if the line goes down, it means something's decreasing. You kind of know that much. And they're very related to the bar graphs we did in Investigation 1. Really, you can turn this into our bar graph by putting the dot in the middle of the bar. And now suddenly you see how I've got a bar here. And then I could put another bar so that the dot's in the middle of it. That's all this is. But then they connect the middles of each bar into lines, a linear fashion. So instead of, that makes me think more of amounts. And this makes me think more of like change over time. In this case, what are we comparing? We got Margie's height. What over what? What to what? Y-axis is labeled in inches, her height. Okay, Margie's height compared to over the course of her age in years. Good label on the X, right? This is X-axis, Y-axis. And we can answer questions from the line graph, height in inches, 8th birthday to 14th birthday. Which year did she grow the most? Okay, so I'm going to get rid of my scribbles here. On a bar graph, you'd find your biggest bar and see which year it corresponds to. And then you would, you would actually look for the biggest change in bars. It wouldn't work as well. But in this case, it works real nicely. If you're looking for where something grew the most, you're looking for a change. Where does, from one year to another, this is even years here, does it change the most? This goes from, here's our estimating, 48 to maybe 50 here, right between 52 and 48. So that's 2 inches. And again, 2 inches. Up here, it looks like the line barely slants. It's a clue it barely changed, maybe an inch. 2 inches. Now here starts to get interesting, right? This looks like from 60, we get to 60 from just over 56, so maybe 57 would be 3 inches. So that's our number 1 right now. And yet, you're looking for dramatic slants, especially growing. Ideally, they're going up. You usually don't shrink. And this one is real interesting. We go from 52 on the money up to that 57 we talked about. So that's 5-inch change. We can double check that that's what we're reading correctly, but if we're looking for where did she grow the most, we're looking between a dot and another dot in a cell here. Where does it change the most? And so we don't put 5 for an answer. It asks during which year did she grow the most, and her year would be her 10th to her 11th birthday. So the year that she was what age? If it was after her 10th birthday, then she was 10 during that year. So which year? Her year 10, or when she was 10 years of age. If we do any more work with this, I'll let you know. But for the practice, I would like at least for you to choose 2 average ones and 2 of the line graph ones. These are really good skills, especially line graph. I just feel like is an underrated skill to be able to do. So pick 2 from A through E and 2 from F through H for me to check, please. Thank you for doing your very best.